Hello, we are Team One. For this project, we were tasked with solving water pollution caused by industrialization. My name is Shane Clark. I'm an environmental engineering major.
I'm Olivia. I'm in the aerospace engineering and mechanical engineering major.
Hi, I'm Elsa, and I'm a biological systems engineering major.
I'm Ryan. I'm in mechanical engineering major.
So when we were first looking into this issue, one of the first things we found was that 771 million people lack access to clean drinking water, which is nearly 1/10 of the global population. So we want to try and reduce this number by reducing pollution caused by factories. And to do this, we want to prevent it at the source. And specifically, we chose to prevent pollution caused by the electronics industry. We chose the electronics industry because we found that it uses lots of water. In fact, a single computer chip requires up to 10 gallons of water during production. And as this water is used, it gets contaminated with lots of heavy metals and other inorganic solids that make it really unsafe to drink. And since for the production of these computer chips, they need to be clean water, they just are forced to dump it out into the environment where people are drinking it. So Olivia will talk about how we came up with our solution.
Thank you, Shane. So when we did a lot of researches to find a solution for this challenge, we mostly only found the existing solution for after treatment, but we wanted to focus on our preventing the pollution so that it will not affect the environment at all. So our main solution is to filter out the metal and the clean water. We designed this solution so that our intended user is only electronic industry, since we designed it to be attached to the electronic industry factories. But it does not specifically means that it only benefits the industry. As you said before, our problem is lack of clean water, so our design solution focusing on benefiting both industry and the people around the factories. So by filtering out the metal, it can benefit the industry by reusing the expensive or rare metal, and by filtering out the clean water, it can benefit other people who live around the factories. Now, Ryan gonna talk about our design and the prototype.
Thank you, Olivia. So we are the first is the design process. At the beginning, we researched the various of the sensor and the way to remove heavy metal in the water. And since we are focusing on the electrical industrial, so the only one polluted water we treated with is the heavy metal water. So we use TDS sensor to monitor the pollution level, and also use the filter and anode to remove the water, the polluted water. So in the circuit, there's two sensor, and there are one LED RGB and two LED. So at the first step, the water gets into from the input way and in anode to form precipitate of the heavy metal, and the filter will filter out the rest of the metal from the polluted water. And at the end of the process, the TDS sensor will check the water to check whether it's polluted or not polluted. So there's one pump to make apply pressure of the water to force it go through the filter, and another pump is to rotate the outer of the filter to block the water because the filters usually need to exchange up. So there's only a button to control the whole system is turning on or turning off. The LED RGB is to show feedback of the people, like the status of the home devices is turning on or turning off. And the two LED, one represents the filter needs to exchange, and the another one is to represent the filter is safe to use. Now Elisha will talking about the testing outcome.
Thank you, Ryan. So basically for testing, we tested the TDS sensor and a water level sensor. So the TDS sensor was for checking how much metal was in the water. And so we tested this by putting small amounts of salt into water to simulate the heavy metals, and we found that the readings for this were pretty accurate and fairly linear, but the problem was that the threshold for the readings was really low. So like we added like a fourth a teaspoon of salt, and it was already beyond what the sensor could read. So if we wanted to improve our project, we would need to find like a better sensor that could withstand, that could like read a higher level of concentration. And so next was the water level sensor, which was to make sure that the prototype would not overflow in case there was any issues with the pipes or the filter. And so to test this, we put the sensor in a bucket of water and we slowly lifted it and saw how the measurements changed, and we found it was not very linear. So we would need to find some other way to like improve the readings so that they would be more accurate. And for further improvements for our project, we would work on finding better sensors based on like our test results, as well as making our prototype waterproof so we could run the whole system together and see how effective the sensors are with the circuit and the water, as well as figuring out how to like scale up our design and integrate it into factory so that it can be added to like the pipe system of like the water from the metal production is coming through, and then working on how to like best like create the prototype out of different materials. And that's it. And thank you for listening, and if you have any questions, please contact us via our email.
Thank you.
Thank you.